Okay, Assalamualaikum and hi everyone. So today we are going to enter a new chapter 9, differentiation, second last topic for this semester. So for chapter 9 we have 5 main subtopics, which is this is a derivative of a function. Basically we are going to learn about first principle and then rules of differentiation. Basic differentiation, what you have learned in high school, basically the same thing apply here. And then we are going to see differentiation of exponent, log and trigo, and then we are going to see how to do implicit differentiation and parametric differentiation. So you have 5 subtopics to cover for chapter 9. And as I told you before, chapter 9 akan masuk dalam exam. Okay? So here we have 5 main subtopic lah. Kita akan belajar first principle, basic rule, differentiate these 3 things, parametric and implicit. So for this video, we are going to focus on this first subtopic. Okay, 9.1 first principle. Okay, so what is a first principle? So we have, okay, mana saya punya ni? Okay, so derivative of a function. So we can differentiate a function by using a first principle. So what is a first principle? First principle. So this is the formula for first principle. We have f prime x, obviously, because we want to differentiate. Kat sini ialah f prime x, okay, which is the same thing as dy over dx. So first principle, the same thing as limit. Okay, kamu dah belajar limit in chapter 8. So we have limit. This is the formula fx plus h minus fx over h when h approaches to 0. So this is the formula. So you have to memorize this formula lah. Okay, so let's just proceed into example 1. We have by using first principle. Okay, the question specifically minta by using first principle, so you have to use first principle. Okay, kalau kita differentiate secara biasa, saya rasa semua orang tahu macam mana nak differentiate. Fx equals to x square. Kalau kita differentiate fx equals to x square, kita akan dapat 2x, right? Kenapa jadi macam tu? Equals to 2x. Okay, so saya rasa semua orang tahu macam mana differentiate x square. So by using first principle, we have to use this formula. So what we are going to do is, okay, so the formula is f prime x is equals to limit h approaches to 0. Okay, so here we have fx plus h. So take x plus h as your x. Okay, so kita gantikan x kita dekat function ni, sebagai x plus h. So we replace x here as x plus h. Alright, so that will be x plus h square, right? Your function ini sebenarnya fx sebenarnya. Okay, fx sebenarnya, tapi x kita ialah x plus h. So we are going to change this into x plus h square. So this one is fx. So basically fx kita ialah x square lah over h. Alright. Okay, so now this just the same thing as your limit. Your prior knowledge for chapter limit tu akan apply dekat sini. So apa yang kita akan buat? So kita akan expand dulu yang atas. So we are going to expand your numerator first. So we will have x square plus 2hx plus h square minus x square over h. So x square minus x square, kita akan dapat 0, which is we are going to end up with 2hx plus h square. Okay, ingat dalam limit aim kita ialah, kalau aim untuk rational function, limit kita kena cancel out numerator dengan denominator. Tersasul denominator. So the same thing works here. Kita kena cancel out lah. So to cancel out, kita kena factorize dulu. So what can we factorize? Yang ni kita dah cancel kan? Ini dah x square minus x square dah jadi 0. So we have 2hx plus h square. So we can factorize h di situ. So we can factorize h. So we will have 2x plus h over h. Alright. So now you can cancel out h. So we are left with limit h approaches to 0, 2x plus h. Okay, so now just case 1, substitute the value of your limit. So ingat, ini ialah h approaches to 0. Substitute dekat h, bukan dekat x. So now the answer is equals to 2x plus 0, and then it's gonna be 2x sahajalah. Okay, so the same thing here. Kalau kita differentiate cara yang biasa, basic differentiation kita, kamu akan dapat jawapan yang sama, but this is how you use first principle. Okay, alright, so let's try one more question. We have fx equals to square root x plus 1. Okay, alright, remember this is your formula, fx plus h. This is basically your fx, but replace your x with x plus h. Okay, so we're going to do that for example B. Alright, so let's see. We have f prime x. Okay, kita tulis dulu lah formula kita. We have limit h approaches to 0, fx plus h minus fx over h. Okay, so that is your formula for first principle. So now we have to substitute. This is your fx, so we have to replace your x with x plus h. So this x replaced by x plus h. Okay, it's replaced by here. Alright, so you're gonna be the expression gonna be like this: square root x replaced with x plus h, so it's gonna be x plus h plus 1. Okay, minus fx is square root x plus 1. Okay, this one kita replace tadi, over square root h. Over h. Okay, so now back to limit. Topik limit kita. Apa yang kita akan buat kat sini? Kita ada square root minus square root. Apa yang kita akan buat? H approaches to a constant, so we are going to multiply by conjugate. Okay, so dekat sini kita akan multiply by conjugate. Multiply by conjugate. Okay, so we are going to multiply by conjugate, darabkan dengan, so conjugate, square root kita berada dekat numerator, so this is numerator kita, so conjugate dia akan jadi square root x plus h plus 1, so we change the sign here, plus square root x plus 1, so over the same thing we have square root x plus h plus 1 plus square root x plus 1. Okay, alright, so now we just expand a plus b, a minus b. Okay, kita expand a plus b, a minus b. Sebab ingat, the aim here is to cancel out. For rational function, for limit, the aim is to cancel out numerator and denominator. So you don't have to expand everything. Okay, only expand what you have as a plus b, a minus b, which is kita akan dapat a square minus b square. So ini tak perlu usik. Okay, so that's your prior knowledge daripada limit lah. Okay, so we have a square minus b square, so a kita ialah x plus h plus 1 minus x plus 1. Okay, kalau kita square kan, square root tu akan hilang, betul? So now yang bawah tak perlu expand, biar je dia dalam keadaan macam tu, because you know that you want to cancel out. Okay, alright, so numerator kita boleh simplifikan, akan tinggal we have x minus x 0, 1 minus 1 0, so we have only h. So nampak dekat sini apa yang kita akan buat? So here is square root x plus h plus 1 plus square root x plus 1, so we cancel out h pula, and then we have limit h approaches to 0, 1 over square root x plus h plus 1 plus square root x plus 1. Okay, so now we can simply substitute your h into here. Okay, so we have 1 over, here is square root x plus 0 plus 1 plus square root x plus 1. So you will have square root x plus 1 plus square root x plus 1, so that's going to be 1 over 2 square root x plus 1. So that is going to be your final answer. Alright, so that is how you do your first principle. So this one you can do it by yourself. The answer is negative 3 over 3x plus 5 square. Okay, tips dekat sini. Okay, the formula gonna be looking like this. Fx equals to limit h approaches to 0. Okay, fx plus h kita ialah di sini. Okay, so 1 over 3x plus h plus 5 silap, x plus h plus 5 minus fx kita 1 plus 3x plus 5 over h. Okay, alright, so how are we going to do this question? Kita tahu kita nak cancel out, so the tips here is to equate the denominator dekat sini dulu. Okay, samakan denominator yang di atas ini dahulu, and then okay, kamu boleh cuba buatlah apa yang seterusnya. Okay, so this is the answer for C. Alright, okay, so let's proceed. Derivative of a function at any point x equals to a. So basically the same thing, it's just we are going to replace the x here as a. Okay, so ada value lah. Okay, if you look at the example 2, the question said by using first principle find f prime a when a is equals to 1, when a is equals to 8. Okay, so instead of we are going to get a function, we are going to get a value. Okay, so now just the same thing. Okay, let's try for question A. We have fx equals to x squared plus 3 when a is equals to 1. Okay, so here the answer, the formula is f prime x is equals to limit h approaches to 0. Okay, so fx plus h. Okay, fx plus h, which is your x here is 1. Okay, x kita ialah a kita ialah 1. So that's gonna be 1 plus h square plus 3. Okay, boleh So x ni kita gantikan dengan x plus h ataupun a plus h kat sini. Okay, so here minus fa, so fa ialah x square plus 3, your x is a, so that's going to be a square minus 3, so 1 square plus 3. Okay, over h. Alright, kalau confused, kita buat je benda yang sama, fx plus h minus fx. Okay, tapi kita tukarkan x plus h menjadi a plus h, so dia akan jadi 1 tambah h lah. Okay, x dekat sini kita tukarkan jadi 1. Okay, the same thing as before, cuma kita tukarkan x kita menjadi a. Alright, so now nilai dekat atas tu kita boleh expand, so we are going to get limit h approaches to 0. We have 1 plus 2h plus h square plus 3 minus 1 minus 3. That's gonna be minus 1. Okay, betul ke? Minus 1. Alright, so over h. Okay, so now 1 minus 1 obviously 0. 1 minus 1 akan dapat kosong. So we have 2h plus h square. So you know you want to cancel out for limit, so we can factorize h there. So we have limit h approaches to 0. Here is your h, so we have 2 plus h over h. So cancel h, we are left with function 2 plus h. So your h is equals to 0, so we are going to get 2 plus 0. The answer is 2. Alright. Okay, so that is how you find your first principle when x is equals to a. Alright, so okay, let's do question B. So quickly do question B. So the same thing as before sebenarnya, kita just use the formula. We have f prime x equals to limit h approaches to 0 fx plus h. Okay, tapi dia bagi nilai a kita, a ialah x lah basically. So that gonna be 1 over square root a plus h plus 1. Okay, boleh nampak ke? X kita gantikan sebagai x plus h. Okay, x kita ialah 8. Alright, so minus 1 over fx kita ialah 1 over square root x plus 1. X kita ialah 8. 8 plus 1. Okay, so over h. Okay, alright, so we simplify first. We have limit h approaches to 0. We have 1 over square root 9 plus h. minus 1 over square root 9 ataupun 3 kat sini over h. Okay. Alright. Okay, to make it simple, here, kita tak nak lah ada fraction over fraction over fraction. So, we are going to equate the denominator for the numerator kat situ. Sama macam apa yang saya cakap for the previous example. So, kita samakan denominator dulu. We have 3 minus square root 9 plus h over 3 square root 9 plus h over h. Okay. Kalau kamu nak simplifykan, over h ni kamu boleh letak dekat luar pun boleh juga. Tak ada masalah. 1 over h pun boleh juga. Alright. So, for this part, 3 minus square root 9 plus h, we are going to multiply by the conjugate. So, we will have limit. Okay, saya bawa keluar lah yang tu supaya nampak tak serabut. 1 over h. So, here you are going to have 2 minus square root 9 plus h over 3 square root 9 plus h. So, we are going to multiply by conjugate. So, that's going to be 3 plus square root 9 plus h over 3 plus square root 9 plus h. Okay, so simplify lah. So, the answer here is 1 over h. Atas, ingat, you don't need to expand everything. Only expand a plus b, a minus b. Okay. So, obviously, we're going to expand yang dekat atas tu. So, here the answer is 9 minus 9 plus h. So, yang bawah akan jadi 3 square root 9 plus h. 3 plus square root 9 plus h. Okay. So, now, yang atas, nampak yang atas ni hanya tinggal h saja. 9 minus 9 obviously akan jadi 0 lah. So, akan tinggal negative h dekat situ. Okay, nampak negative h. So, mana saya nak sambung ni? Okay, saya kecilkan sikit. So, here. Okay, so we are going to have limit h approaches to 0, 1 over h. 9 minus 9, 0. Negative 9h. Atas akan tinggal negative negative h. So, yang bawah, nak expand boleh. Tapi tak perlu buang masa kamu untuk expand kan. Sebab kita akan just substitute the value of h. So, tak perlu. So, biarkan sahaja di dalam keadaan macam ni. 3 plus square root 9 plus h. Okay. So, now we can cancel out h. So, just substitute. We have negative 1 atas over 3 square root 9 plus h. 3 plus square root 9 plus h, which is h is 0. So, your answer is negative 1, 3 times 9. 3 plus 3, that's going to be negative 1 over 54. Okay, so a bit complicated, but make sure you know how to use first principle, okay, to find your derivative. Okay, saya tahu kita akan menjawab soalan yang objektif, but you still have to know. Maybe dia akan tanya the next step in first principle. Okay, alright. So last part for this video, we are going to see how to determine the differentiability of a function at x equals to a. Okay, so now you know that how to find a continuity. You know how to find a continuity based on chapter 8 limit. So as what you can see from here, a function is differentiable at point. If a function is differentiable at a point, then the function is also continuous at that point. Okay, if a function is differentiable, that means the function is also continuous. Okay, what do you know by continuity? Continuous. Okay, first f is defined. Second, limit right hand side must be equals to limit right hand side. So that's going to be the same thing. Okay, continuity and differentiability is the same thing. Okay, however, a function may be continuous at a point but not differentiable. Okay, so how to determine a differentiability at a point? So we have to determine limit x approaches to a from left hand side, left-sided limit is equals to limit from the right. Okay, so we have to use this formula basically. Okay, we still have to prove the right-sided limit is equals to left-sided limit. So the same thing as continuity sebenarnya. So okay, kita terus kepada example 3. So we have a piecewise function. So you know that this is x less than 0 is x approaches to 0 from the left because we have x less than 0. And this is x approaches to 0 from the right because we have x greater than 0. So we use the formula. Kind of look like a first principle formula. Cuma bezanya kat sini kita tak ada fx plus h. Okay, we have fx minus fa over x minus a. So we have f prime a. So our a here is 0. Is equals to, we want to find first limit x approaches to 0 from the right. So the formula is fx minus f0 over x minus 0. So that's the formula. Okay, so what is the function for x approaches to 0 from the right? We have x square. So you will have limit x approaches to 0 from the right. So your function fx is ini 0 from the right. So your function is x square. So we have x square minus 0 over x. So here the answer is limit x approaches to 0 from the right, x square. So we just substitute 0 into the, sini ialah x. Okay, sini ialah x. So the answer here is simply 0. Okay, so now let's take a look for limit x approaches to 0 from the left. So the same formula, fx minus fa over x minus 0. So a kita ialah 0, tulis siap-siap lah, 0. And then here we will have limit x approaches to 0 from the left. So what is the function for 0 from the left? We have 2x minus 0 over x. Okay, so now here you have limit x approaches to 0 from the left. X cancel out, kita ada 2 dekat sini, so a constant 2. So from here you can see that f prime 0 does not exist. Okay, does not exist. So what does it mean by that? Hence f is not differentiable at x equals to 0. Okay, so that is how you find differentiability and also first principle. Alright, okay, thank you guys.